Hi everyone, in today's lesson we will look at the third explanation of the nature of the roots. Now let's have a look at this example. Show that the following equation will have rational roots for all rational values of k. And here's the equation. Now what they're asking is that we have to show that this equation's x answers will be rational. Okay, so it will have rational roots for any rational values of k. So that means that to have rational roots, delta must be a complete square. So that's what we are going to try and show. So the first step is we are going to take this equation and move all our terms to the one side and make sure it is in the right form of ax squared plus bx plus c. Now if I move this k to this side, you will also see that we have two bx terms, if I can say it like that. So we have got ax squared plus bx, okay, and here's another bx. So that means we are going to have to take these two terms and we have to factorize it to make one x term. So here we go. So we have 2x squared plus, and when I take out a common x between these two terms, we will have x and in brackets 2k minus 1. And then we had to move this k to this side, and therefore we have a minus k equals 0. So here we have ax squared plus this is our bx and this is our c. Now what you can do is you can write the x at the back of this bracket if you want to, but I'm just going to leave it like that. I know it's going to be a positive b. So here we go. We want to calculate delta, and we calculate delta with b squared minus 4ac and then doing substitution of the b, the a and the c. So let's do it. So here I write it in with all my brackets, and in the place of b I'm going to put a positive 2k minus 1. There we go. Then we have the minus 4, and in the place of a I'm going to put the 2, and there it is. In the place of c I'm going to put the minus k, and there it is. Now this is a product of two binomials, so first times first, that gives us 4k squared. First times second times a 2 gives us minus 4k, and second times second gives us a plus 1. And then minus 4 times 2 times a minus k gives us a plus 8k. Then we simplify this and we end up with 4k squared, and then minus 4k plus 8k gives us a plus 4k, and this plus 1 we write it down again. So here we have a quadratic equation for delta, and therefore we can factorize this because it's a quadratic trinomial. And we end up with two of the same brackets, 2k plus 1 and 2k plus 1. Because they're exactly the same, we can write it as 2k plus 1 in brackets squared. And as you can see, because this bracket is squared, delta is a complete square. And to get rational roots, because that's what they say, we will have to prove that it has rational roots for all rational values of k. So to get rational roots, delta has to be a complete square. And delta is 2k plus 1 in brackets squared, which is a complete square. So therefore we can just write delta will be a complete square for all rational values of k, because it doesn't matter what rational value k is, it will always have to be squared, and therefore it has to be a complete square. And that is all there is to it. Hope to see you again soon, and see you next time. Bye.